Today we're going to be doing the integral of trigonometric functions. Now, it's going to be a little bit more of a complicated problem. So what we're going to do is we're going to strategize and see what we can do. So, first step is let's see what kind of indefinite integral we have. We have tangent squared theta, secant to the fourth theta, and we need to get the derivative of two trigonometric functions that are multiplied by each other. Now there's a couple things you could do. I'm going to do it one way and maybe I'll do it another way, but for me, when I see this, I think of U-Substitution. So we're going to U-Substitute, and we're going to also use a couple of trigonometric identities to manipulate this integral so that we can solve it. So what I like to do is I decide, okay, what's the derivative of tangent? The derivative of tangent is secant squared theta. Okay, well, what's the derivative of secant? The derivative of secant theta is secant theta tan theta. So we could possibly use this one, secant theta. If we pull out a secant theta tan theta, sure. But if we pull out a tan theta, we'll only have a 1 tan theta. And you have to remember there's an identity that we might need, which is tan squared theta plus 1 equals secant squared theta. Now if I pull out a tan theta, I only have 1 tan theta. Also, we could think secant theta is what? Is 1 over tan theta, okay? So 1 over tan theta, that was tan over 4, so then this will be, cross these two out, it'll be 1 over tan squared, will become secant squared. And that could work too, maybe, I don't know. But I like this. This seems like the safer route, seems like it's easier. We could pull out a secant squared, and then we'll still have a secant squared, and we can change that into tan. So let's try that. So, if we pull out a secant squared, this is equal to secant squared theta d theta, right? Right? So, from here, what about secant squared theta? Well, if tan squared theta plus 1 is equal to secant squared theta, secant squared theta is equal to tan squared theta plus 1. So that's right there. So the integral perfect. So we only just rewritten it. Okay? We haven't did any math. We just pulled it out, changed it, what's equal to each other. So now we can distribute this tan squared theta to tan squared theta plus 1. What's the matter, buddy? You don't like math? So this becomes tan squared times tan squared. Remember, you add exponents, that's tan 4 theta plus tan squared theta secant squared theta d theta. Right? Now we could make this secant squared theta tan squared theta, and then distribute it again, or we can use U-substitution. If we let tan theta equal U, well, what's the derivative of tan? Derivative of tan is secant squared theta. And what do you know? We have secant squared theta right there. So, if we let U equal tan theta, then du is equal to secant squared theta d theta. Okay, so if we just substitute what we have so far, we have u to the fourth plus u to the 2, right? Now secant squared theta d theta is equal to du, so we're going to substitute du there. All right, well, this is just taking integrals of an addition problem. So you could distribute your integral to both sides, and that will come, remember, you take your exponent, add 1 over whatever your exponent is, plus u to add 1 over whatever your exponent is. And because it's an indefinite integral, we're going to add c, and what does that come out to? That comes out to, if we simplify that, this will become 5. This will become 5. 2 plus 1, that becomes 3. 2 plus 1, that becomes 3. And there you have it. But we started off with trig functions, and we're in u. So let's go back. So whatever u is, we're going to plug in for tan theta. And let's do that over here. So u to the 5th, u is equal to tan theta, so this becomes and there you have it. All you do is, remember, we let u equal tan theta. So to go back, we substitute tan theta in for u. And this is your answer. Using U-substitution. So hopefully that was helpful. And good luck on your studies.